Hello everyone, in this video we will learn about the distance formula and its application. Distance formula is a formula which is used to find the distance between any two points given in a plane. Suppose we have a plane, that is xy plane, x dash is the x-axis, y dash is the y-axis and O is the origin. We have been given 2 points here, P and Q. The coordinates of P are suppose x1, y1 and the coordinates of Q are x2, y2. Then to find out the distance between these 2 points, that is PQ, we have to apply the distance formula. And the distance formula is PQ is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Suppose we have been given that P is the point which is 1, 4 and Q, the coordinates of Q are suppose 5, 1. And we want to find out the distance between the points P and Q. To find the distance between 2 points, we will apply the formula. First we will write the formula PQ is root of x2 minus x1 whole square plus y2 minus y1 whole square. And then we will apply the values of these all 4 coordinates here. That is root of x2 is 5 minus x1 is 1, 5 minus 1 square, plus y2 is 1, y1 is 4 minus 4 whole square. And this comes as root of 4 square plus minus 3 square, which is equal to root of 16 plus 9. That is root of 25, or we say it is 5 units. This is the answer. So by applying the distance formula, we could find out the distance between the points P and Q, whose coordinates are 1, 4 and 5, 1 is 5 units. And let's learn now how this formula has been derived. And let's see distance formula. This is the x-axis, x dash. This is the y-axis, y dash. And this is the origin. Suppose we have been given 2 points P and Q. The coordinates of P are x1, y1 and that of Q are x2, y2. Suppose this is point P, the coordinates of which are x1, y1 and this is Q, the coordinates of which are x2, y2. We are to find out the distance between them, that is we have to find out the length of PQ. What we do, we draw a perpendicular from P to the x-axis, that is PL. A perpendicular from Q to the x-axis, that is QM. And then we draw a perpendicular from P to QM, that is suppose PN. Here we can see that distance OL is the x coordinate of P, that is x1. The distance OM is the x coordinate of Q, that is x2. So we can say here that this LM will be x2 minus x1. Then this distance PL is y coordinate of P, that is y1. And QM will be y2, that is the y coordinate of Q. It means QN will be equal to y2 minus y1. Now we write here that we have OL is equal to x1, OM is equal to x2, which implies that LM is equal to x2 minus x1. and hence we can say that Pn also will be x2 minus x1. Similarly, we have PL equal to y1, Qm equal to y2. It means Qn is equal to y2 minus y1. Now we can make use of the Pythagoras theorem in this right angle triangle PNQ. So we can write in right triangle PNQ, PQ square is equal to Pn square plus Qn square, right? What is Pn? Pn we have found this is x2 minus x1. What is Qn? That is y2 minus y1. It means what is PQ? PQ is root of x2 minus x1 square plus y2 minus y1 square, or not? Also we can see here that this can also be written as x1 minus x2 square, y1 minus y2 square. Why? Because a minus b whole square is same as b minus a whole square. Combining these two, we can also say that PQ can be remembered as x1 difference x2 square plus y1 difference y2 square. It means you use x1 minus x2 or x2 minus x1 here y1 minus y2 or y2 minus y1, the answer will be coming same. Distance formula is used to find out the distance between the 2 points, or we can say to find out the length of the line segment joining two given points. But we can also have different applications of this after finding the distances. That is, number one, finding the types of triangles. In case we are given all the vertices, then by finding the length of the sides of the triangle, we can find out what type of triangle it is. Like if all the three sides are different, then we can say it is scalene triangle. If two sides are equal, then we can say it is isosceles triangle. And if all the three sides are equal, it is equilateral triangle. And if the sides of the triangle follow the Pythagoras theorem, then it is a right angle triangle. So we can find out the types of triangles. If the vertices are given, then finding the sides. Number two, we can also find the type of quadrilateral. Types of quadrilateral. In case we are given the vertices, then here also we have to find the sides and the diagonals, and we can find out what type of quadrilateral it is. Like if it is a rectangle, then its opposite sides are equal and diagonals are also equal. But if opposite sides are equal but diagonals are not equal, then it is a parallelogram. Same way about the rhombus and square. If it is a rhombus, it's all the four sides are equal. But if it is a square, then it's all the four sides are equal and also both the diagonals are equal. That's what we have to see here. The third thing is we can find the coordinates of a point. Find the point. For a given condition, some condition will be given. Suppose the point is equidistant from 2 points, or it is lying on the x-axis, or it is lying on the y-axis, or some condition will be given. Then we can find out the point according to the given condition. Then we can also find out the collinearity of points. collinearity of 3 points. Collinearity means if the 3 points are lying in a line. We will discuss about this in the next video. So this also can be done by using the distance formula. Now we will discuss some of the examples on the application of distance formula. The first one is prove that the points A minus 3 0, B 1 minus 3 and C 4 1 are the vertices of a right angled isosceles triangle. For the solution, first we write the vertices, the points which have been given to us. You have been given A is minus 3 0, B is 1 minus 3 and C is 4 comma 1. Then we will write the distance formula. Distance formula for any 2 points P and Q, PQ is root of x2 minus x1 square plus y2 minus y1 square. Using this we can find out the side AB. AB will be root of x2 minus x1, that is 1 plus 3 square, plus y2 minus y1, that is minus 3 minus 0 square, and that comes as root of 16 plus 9, it is root of 25, or we can say 5 units. Then we find BC. BC is root of x2 minus x1, that is 4 minus 1 square, plus y2 minus y1, that is 1 plus 3 square, which is equal to root of 4 minus 1 3, square of 3 is 9, 1 plus 3 4, the square of 4 is 16. This is also root of 25, or we can say 5 units. Now we find side AC. AC is root of 4 plus 3 square plus 1 minus 0 square. This comes as 7 square means 49 plus 1, it comes as root of 50. This we know is 25 into 2. So we can write this as 5 into root 2 units. We find here AB is equal to BC. Two sides of the triangle are equal. Therefore, triangle ABC is an isosceles triangle. Now also we are finding here AC square is root of 50 square, that is 50. And we find here AB square plus BC square is 25 plus 25, which is equal to 50. So we find here that AC square is equal to AB square plus BC square. So Pythagoras theorem is being followed. So we can say that triangle ABC is right angle triangle. And combine these two, we find it is isosceles right angle triangle. So we can write hence triangle ABC is right angled isosceles triangle, and that's what we have to prove. The next example is if P x comma y is equidistant from the points A 6 minus 1 and B 2 3, then prove that x minus y equal to 3. Sometimes the same question can be asked to you, find a relation between x and y. The meaning of the question is same. To find the solution in this case, we write P has been given to us x comma y. Point A is given as 6 comma minus 1 and B is given as 2 comma 3. According to problem, we have been given that PA is equal to PB. We know the distance formula For any 2 points P and Q, that is root of x2 minus x1 square plus y2 minus y1 square. Applying this formula, we can write here root of PA, that is 6 minus x square plus minus 1 minus y square is equal to root of PB, that is 2 minus x square plus 3 minus y whole square. Squaring both sides, we get this is 6 minus x square plus this can be written as 1 plus y square, because if we take minus common, the square of minus 1 is plus 1, equal to 2 minus x square plus 3 minus y whole square. Simplifying this, we get 36 minus 12x plus x square plus 1 plus 2y plus y square. Applying the identities of a minus b square and a plus b square, equal to 4 minus 4x plus x square plus 9 minus 6y plus y square. We find here this x square and y square cancels this x square and this y square. Using the transposition, we get minus 12x plus 4x plus 2y plus 6y is equal to 4 plus 9 minus 36 minus 1, which gives us minus 12 plus 4 minus 8x plus 8y equal to 4 and 9 13 minus 37, that is minus 24. If we divide it by minus 8, we are getting x minus y equal to 3, and we have to prove the same thing, so we can write hence proved. Like this, we can apply the distance formula in various type of problems. In the next video, we will learn about finding the area of a triangle if the coordinates of the vertices are given to us. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.